Okay, so in the second part of this video, I'm going to show you how we can completely destroy this pipeline. So I got AI to basically build a pipeline that took data from like a MOP source, landed it in Snowflake, and then ran some dbt. And a really common problem that people face is there are issues with the upstream data. So what I've done is I've actually created a branch, which I'm going to show you, and that's called Feat Demo AI Pipeline. And I've done something very bad. I've made a load of commits which are really, really bad. So in this final dbt SQL, I've put in the name of a random column and I have a formatting area. In the schema file, maybe not this one, but in one of them, like I've messed up the formatting. In the original file, I've got some incorrect names of columns here. Think of this as like the work that a junior data engineer would do. It's really, really, really bad. But it's also quite complicated. So if we look at our Python file, you'll see that we've also amended some of these columns. So instead of ID, we've got ID underscores, we've got post ID underscores. This is a breaking change to the schema. Like if this goes through, then the DBT will break. So let's run this and see what happens. Okay, so we're back, and now we can see exactly what the agent's done. The agent has worked out there are multiple injected bugs. There's a missing import, there are environment variable typos, and there are a load of keys which have been incorrectly identified. The agent has committed a fix to this particular branch, and it's then triggered this run. So if we go ahead and take a look at that run, we can see that it's not done very well. So let's go and take a look at. But then you can also see that it's triggered this run. So let's go and take a look at that run. All right, so this is the run. And we can see the Python task has completed. Unlike one of the first issues where we were writing to the wrong database, this one has written to the correct database, which is great. But now we have a different error message. Specifically, it looks like this YAML is completely wrong. But instead of closing the loop by running the session again, in this case, we've actually decided to trigger an agent fix from a pipeline. So what this allows us to do is essentially close the loop on what's happening. The agent can observe its behavior, but it can also observe the results of the behavior. And now that it's seen that there's an issue with the DBT, it's gone ahead and it's run all of that. So we can now click into the second run, which is its second iteration of fixing this bug. Okay, cool. So this is the second iteration of the bug. And in this case, we can see that actually everything has passed. Not only have we managed to run the Python code, but we've also managed to run the DBT core processing, which is really cool. And we've done something really simple. We've just done a couple of data models, but this demonstrates how you can actually do everything end to end. And now that this is in another branch, all that remains for us to do is to create a pull request that can that can actually solve the problem. If we take a look at the commit history, you can actually see the history of exactly what's happening. So I basically came in and I made some stuff break. I said that we're going to break the Python. The junior data engineer is going to write some bad DBT. They're going to forget how to author their YAML file, and they're also going to forget to select the right column at the end. As a result, we've got a few commits from the bot, basically putting this back. And we can kind of see exactly what's happened. So we have basically the beginning of the beginning of the SQL, which corresponds to the original commit that we did. We have the well formatted schema file. We have the staging model as it should be. Again, another well formatted schema file. The source documentation. This is the pipeline itself, so the Orchestra pipeline with everything nicely parameterized. And then finally, we have the actual Python code. So all of this is kind of like, exactly what we had in the first two commits, and then we kind of destroyed everything, and then we kind of fixed everything again. But hopefully that demonstrates how you can create an end-to-end flow using the Orchestra Runtime, not just to fix pipelines, but also to build pipelines. We think it's really powerful combining a AI engine with a runtime because it means that you can close the loop. So if you like this, be sure to follow and drop us a like.